everybody able to get the chart? We're going to ask 4 people whether they have an e-reader or not. The study itself found that 19% of all population of people have an e-reader. Okay? Is that a low probability or a high probability? Low. How many of you guys have an e-reader? An electronic reader like a Nook? You probably can read on your iPad, right? If you have an iPad, you can read on your iPad. I have one, Mercedes has one, so Raven has one, so we're probably like 20 people in here. So 3 out of 20, that's about 1/7, so what is that? Less than 20%, so we're almost in that bracket there, right? So that's what they're asking. So your probability is small, and your 1 minus this is your Q. Now do your binomial. Easiest way to do this, 4.19, start at the 0 and keep changing that. So 3 decimals. Where do we expect our larger numbers to be? On the lower numbers or the higher numbers? Lower. Why? There's a low probability of success. So am I going to get more people saying that they don't have this? It's kind of a reverse thinking. 0 means they don't have this, right? So didn't we see that most people didn't have it in here too? Right? So isn't that where our higher numbers are going to be, if you think about it? So what percent did you, what probability did you get for this? 430? 430. Okay, next one. Pretty close, right? Next one. Thank you. What should these all equal up to? 1. This makes a probability distribution because your probabilities fall between 0 and 1, and the sum of your probability adds up to 1. It makes a binomial distribution because you have 2 choices to say, yay, I have one, nay, I do not have one. 4 trials, fixed probability, and my x is my 0 to 4. Good so far? We expected more people to say no, just like in this class. More people said no than yes. God bless you. God bless you. Okay. So we didn't expect a lot of yes responses, in other words. So the 0 means we have less yes responses. So now we're going to make a graph. We're going to see who owns an e-reader. Your x values go here. God bless you. You can have 0, 1, 2, 3, 4. People who own e-readers. What goes on my y-axis? My probability, my p of x. This is just like your relative frequency. Your relative frequency, we had class intervals, but now we're just going to basically keep the same type of concept. We're still doing a bar graph, but we have our plain x values. So again, make your y go from 0 to 45 cents. If you can go by nickels, if you can't, go by 10 cents. And just kind of estimate in between. Okay? Try to keep them evenly separated. It's not like mine, then they're a little bit off here. So try to keep them evenly separated. I didn't give you graph paper, so do the best you can. Make your bars touching. If you want, you can certainly put your probability on top of your bar. If you find your numbers are too far apart, put your numbers out there. Maybe make it look a little bit better. Okay, this is my 0.404, my 1.42, my 0.142, my 0.022, and my little guy over here. Okay, where is the skew to this graph? To the right, because we said the skew, if the probability is less than 1/2, my larger numbers will be up here in the smaller x values, so my tail will go to the right. If my probability is 0.5, exactly half, and it kind of makes sense, half and half, then you have a normal curve. It's symmetric about the middle. If your probability is greater, like if this probability was a 0.81 instead of a 0.19, my larger numbers would be down here. I would expect more people to say yes. If I asked you guys who uses their iPhones to read something, anything off the internet or anything else, who uses their phones, whether it's an iPhone or a Droid or whatever. See my probability get a lot higher? Where would my larger numbers be? Down here, right? So where would my skew be? To my left, where the lower numbers are. So it makes sense, right? Okay, now, if we wanted to find the mean, and we wanted to find a standard deviation, we could put this in your L1, L2. So let's do that. Put it in your L1, L2. Okay, so what did we get for your mean? 0.759? Okay. So what does this mean to me? Well, how do I translate this? 0.759. Where does this fall in between? Somewhere between the 0 and the 1, right? Closer to the 1? Aren't these where most of my numbers are? Don't I expect my average to be closer to where those guys are? Right? Because with the skew, doesn't the mean fall to the left if the tail's going to the right? So that makes sense to me. So I don't get a sample standard deviation because my total was 1, so I can't do 1 minus 1, but I can get a population standard deviation. And what would that be? 7. Thank you. Thanks, Raven. And my variance is my standard deviation squared. You want to go to VARS. You want to do a true variance. You want to go to VARS. You want to go to statistics. And you actually want to square your standard deviation. Because you rounded here. So go to VARS, get a true standard deviation. Let your calculator square the true standard deviation. So what's the variance? 611. Thank you. Now, this works great when we have a table that has these amount of numbers. Even 8's not bad, 10's not bad. I can enter them in my calculator. But when I get a larger numbers and I want to find the mean of, say if I ask 100 people, if I ask 100 people and I want to know based on what the average is, what they're going to say, I certainly don't want to make a table for 100, right? So we have these 3 little formulas. These 3 formulas will calculate the mean and the standard deviation and the variance off of any of your probability distributions. Now, with 4, it may just be easy to put it in your L1, L2. With 100, I certainly don't want to make a table for 100 and put that in my L1, L2. So that we see that it exactly works, I wanted to use it on a small one. So to find the mean, we take, which is the same as your sample mean in your calculator. Your calculator knows no difference between a population and a sample mean. They are the same thing. We take n times p. N is the number of times we did this. P is the probability of success. When you multiply this, you should get 0.759, or really, really close to that. It's rounded, so 0.76. We're kind of doing a little rounding here versus in our calculator. To find your variance, this time we have to find our variance first. Notice all we did was took that and multiplied it by q. So our variance squared says n times p times q. Well, you just did n times p. So take 0.76 and multiply it by q, which is 1 minus your p. So when you multiply this, you get 0.616. Okay? Very close to the variance we had over there, 0.611. We're a little off because your table is a little different than this, but not by a lot. Now, to find your standard deviation, we just take the square root of this guy. So the square root of this and this becomes 0.785. So our numbers are in the ballpark. Our rounding's a little bit different whether we're using our table or we're using your calculator. Okay, your table is probably a little bit more exact in there because we've got some rounding going on here. But if we had a table bigger than, say, 20, and you don't want to have to put that in your L1, these formulas would come in really handy to find the mean, the standard deviation, and the variance. Does it make sense? Yeah. You can absolutely do either. When you would really want to do those is when we do something with, just say, I asked 100 people. On the average, what will they say? On the average, what are they going to say? You know, the same as any of those. If your table is too large, don't put it in your L1. Yeah. But I wanted to show you on a small scale how this works, because on the large scale, I certainly don't want to do a table of 100. But everybody okay with this part? And this is the part that we finish with last. And it's kind of a nice way to finish because sometimes we do ask more than just a few people. We ask a lot of people. And we have this binomial distribution for a lot of different things. Now, if you kind of look in your book, at example 8, we'll try this. I have to keep turning it over here. Okay, this is something you might see on your regents as well. In Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Find the mean, the variance, and the standard deviation for the number of cloudy days in June. So I'm going to tailor this to June. How many days are in June? 30 days in June. So I'm trending. If 56% in a year are cloudy, I should expect 56% of the days in June to be cloudy, should I not?
That's right.
Great. So what's my P? 0.56. Good. What's my Q?
It's going to be 44.
0.44. Good. Now, if I made a table, I'd have to go from what? 0 to 30. And then I'd have to put them in my L1, L2, and add them all up. And all I really want to know is the mean, the variance, and the standard deviation. So instead, we're going to use your formulas. Start with your mean. Your mean is the same as your x. Your sample mean and your population mean are always the same. So we take your n, which is 30, times your probability, and we come up with the mean. Remember, the mean should be one more decimal than the x values, and the x values are discrete. They're whole numbers. That's the day, the date, 1, 2, 3, whatever. Your variance is next. Your variance is n times p times q. Well, you did your n times p, and now multiply it by your q. Do your variance next. And your standard deviation is your square root of this guy. Which totally makes more sense when you look at it this way.
I wish I knew this from the start.
Well, I never asked you your mean or your variance before we got here.
This is simple.
This is simple. This is nice.
I see.
So if you're looking for something that has like a lot of entries, first of all, you don't want to make a table that long. You don't want to do all your binomial calculations that long. And then on top of that, put it in your L1, L2. You can default to these little formulas. Okay, you guys try it 8. But I can't move it down any further. Having your mean, your variance, and your standard deviation. I'm going to do it over here because I'm kind of out of space down here. So for the month of May, we said we had 31 days. What's your probability that it will rain? Or be what's the probability that will be clear? 0.44. What's the probability that it will not be clear? 0.56. Almost the same way they did that, but look what they did. They switched around what their success is. Over there, their success is being cloudy. Over here, it's being clear. Do you see the difference, the way they word the problem?
They tried to get us.
Oh, they sure did. So, the mean. What's the mean going to be? What'd you get, 13 point what? 13.64? 13.6? Okay. And then the variance, n times p times q. Take what you did for n times p and multiply it by the q. Again, if we were looking for your percent of clear days, it's 44% as a trend. If your month has 31, we would multiply 44% times 31. That's why they do it for your mean. And then they multiply it by the q. And you should get your variance to be 7.6. And then take your standard deviation, which is the square root of this little guy. And what do you get? 2.8. 2.8. Okay? Are we good with this? Or if you feel you'd like to make a table, you can